Okay, so today we're going to do something kind of a little bit different than before. First of all, we're going to look at these graphs of first derivatives. And after we look at those graphs, we're actually going to try a couple AP exam problems today. And they're ones that you can have success with and that you'll get correct. Without a doubt, these are probably the most common pieces of content that we can ensure that you're going to see on the AP exam for multiple choice type questions. And so it may look obvious, but it's going to be a little bit less obvious than what you think. As I look at this guy right here, f of x, I want to know where it's increasing. Okay? Talk for 20 seconds with your partner and see if you can think about where f of x is increasing. Talk. Go. Okay, so I'm going to tell you right now, it's increasing from negative infinity to negative 5, union with 2 to infinity. Now, is there anybody out there that looked at where it was above the x-axis? Now, you got used to doing what we were doing the past couple days. When you were asked to do that, remember that you were looking at the derivative. Is this the derivative or is it the original function? It's the original function. So when we say when is it increasing, we're looking for when it's on its way up, when the first derivative is positive. So the red areas are where it's increasing. You're looking at the original function here. Does that make sense? Okay, so where is it decreasing? Good. So concave up, concave down. Remember, we're looking at the original graph. Which derivative test tells us about concavity? Very good, Taya. The second derivative test. But we don't have a second derivative, do we? So we just kind of look at the graph. You tell me where it looks like it changes from concave down to concave up. Great idea. I think here it's concave down, and here I would say concave up. I would say that would be about the point of inflection. Everybody agree with what Carter suggested? Okay, so we're going to say that it's concave up from, I'm going to go negative 2 to infinity, and concave down from negative infinity to 2. Whoop, negative 2, negative 2. When we look at the graph, we can determine the local max. What is the coordinate of the local max? Yeah, negative 5, positive 4, right? The x value is negative 5, the y value is positive 4. Henrik, if you could keep it quiet, appreciate it. Just a little loud with the knife there. I'm sure. All right. And then local minimum, I've got 2, negative 3. And then the inflection, Carter kind of suggested here that maybe the inflection point happened right about here. So that'll be negative 2, positive 1. So that's when we look at the original graph. So the biggest mistake that people make when they're taking the AP exam is that they don't look at what kind of graph they're looking at. Most of the time, they're going to give you the first derivative. Now, where is it increasing? Where is the original function increasing? Yeah, wherever the first derivative is positive, that would be from negative 8 to negative 1. Yep, 5 to infinity. Good. So we've got that. Decreasing wherever the first derivative is negative. Negative infinity to negative 8. Negative 1 to 5. Oh, I'm sorry, decreasing. I put it there. Okay. What else does the first derivative tell us? Local max and local min. The local max happens when what? F prime changes from positive to negative. Is there a spot where it changes from positive to negative? Where? Everybody see -1? Now, -1, but notice when we come up with -1, I told you in the past, in order to come up with the y value, you had to plug it back into the original function, right? Do you have a function to plug it into? So we don't know the height of the local max. We just know that it occurs at x equals -1. If we had the original function, we could plug it in. Local min happens where it changes from. Does it ever change from negative to positive? When? X equals -8 and 5. Okay, so today's lesson is really, for the most part, that straightforward, except talking about the second derivative is a little bit challenging. So this is really the only part you're going to have to kind of lean in. First derivative or second derivative? First derivative, everybody agreed? So if I want to look at the second derivative, I would look at the slope of the first derivative, right? So right here, for example, that would tell me that because the slope is positive, the second derivative is positive. The first derivative is on its way up. However, at this spot, we would say that the derivative of the first derivative is negative. So the second derivative is negative. So in order to determine the derivative of f prime, we have to look at the slopes of those tangent lines. Yes? And if you have to think about it for a little while and doesn't just click right away, that would be normal. Gets confusing from time to time. So what is our rule for concave up? A graph is concave up when f double prime is positive. So f double prime is positive from where to where? Yeah, from -infinity to -5. Okay, that's the spot where the second derivative is going to change from positive to negative. So we got -infinity to -5. Does that spot happen again? Where else do we have concave up? Yeah, from 2 to infinity, because then it's positive again. So concave down is going to be wherever the slope of the first derivative is negative. When is the slope of the first derivative negative? -5 to 2. Good. Inflection is the point at which it changes concavity. When do we change from concave up to concave down? -5 and 2. What's different about f double, or what's different about the next graph? F double prime. What does f double prime tell us about? The derivative of the derivative. I heard concavity and inflection. Everybody agree with concavity and inflection? So does it tell us anything about increasing? No. Decreasing? No. Local max, local min, those are out. We can't determine things about that when we just have the second derivative. So the original graph is concave up whenever f double prime is positive. When is this thing positive? -infinity to -3. That's where it's above the x-axis. No, because I'm looking at f double prime. And the rule is whenever f double prime is positive, here it's positive, Here it's negative. Better? And then we have union from 8 to infinity. Concave down wherever f double prime is negative. Yep, negative 3 to 8. Inflection wherever f double prime changes from positive to negative or from negative to positive. And that happens at x values of negative 3 and positive 8. We can't come up with the y values, can we? Good. Check out your worksheet. Back to your notes, and let us go over a couple questions. What I would like you to do is make sure you're working in a group of 2 or 3, and I would like you to do your very best to try to come up with an answer, reason through it, and do not shout out the answer. This is taken from 2012. You guys did a few of these when I was gone, right? And I looked through your results, and some of you guys did quite nicely. Okay? But so these are some multiple choice questions. The graph of f prime. So are you given f or f prime or f double prime? F prime, just like we've talked about, right? Focus on f prime. Which of the following statements must be true? F has a relative minimum. Relative minimum means local minimum. They interchange the words relative and local. Graph of f has an inflection point. Graph of f is concave down. And notice 1 only, 2 only, 3 only, or 1 and 2 only, or 1 and 3 only. Think about it. We're going to give you about a minute and a half. We're going to go over it together. Go. Is that?
Do a Band-Aid?
No, I don't. I'm sorry. Okay, take 20 seconds to make a guess. Five, four, three, two, one, and there we go. Okay, f has a relative minimum. Relative minimum means f prime changes from negative to positive. Does that happen at negative 3? Yes, so number 1 is correct. That is truth. The graph of f has an inflection point at negative 2. If we were looking at the graph of f and not f prime, it would look like it changes from concave down to all of a sudden concave up. But we're not looking at f, are we? We're looking at f prime. So in this situation, the deal is in order to have inflection, f double prime needs to change from positive to negative or negative to positive. Can anybody see the spot where f double prime changes from positive to negative or negative to positive? Yeah. So this is f double prime would be the slope of f prime. Changes from positive to negative. So 0 is the inflection point. So this one's wrong. The graph of f is concave down for 0 to 4. So f double prime to be concave down would have to be less than 0. So I'm going to look from 0 to 4, and notice that this function is always decreasing, isn't it? So the slope of the derivative is always negative. So they are right. It is always concave down. So it is 1 and 3 only. Folks, something you need to know, okay? If you took the AP exam and you scored 50%, you would be doing extremely well. This is the class getting this one right. Ready? Go. Twenty seconds. Okay, Morgan, can you tell us how you did this problem? You feel confident, put yourself out there.
Sure. Okay. So I know like it changes from maximum goes from positive to negative. So I said 1.
Letter C. Did you get it? Good job. Folks, can you see how I'm trying to teach you content that leads you exactly to this? And can you understand that if you would have shown up to this class and taken the AP exam at day 1, do you understand you would have known how to do 0 problems? Whereas sometimes other classes, if you showed up, you could kind of, like, you could do the essay. Maybe you wouldn't get a 5, but you probably still, like, work a 2 out of it or something. That's what makes this a little bit different. All of it's new this year. But look at how much you've learned. You're super smart. Next one. What graph are you looking at? F double prime. Always check the graph. You're looking at F double prime. 4, 3, 2, 1, 0, and stop. Okay, here we go. So here's what I do. Here's my approach. And this didn't always used to be my approach, but I'm saying I look at this F double prime. Which intervals is it concave down? I immediately think about the definition. F is concave down when F double prime is negative. So I'm looking for F double prime to be negative. Is this F double prime? Yes. It is. So for this graph to be negative means I look for where it's below the x-axis. So I'm going there to -1 and from 1 to 3. That's where it sits below the x-axis. We're going right there. Everybody see that? If you had to do it again, you get it right, wouldn't you? Yep. It's not easy, okay? Our last one, we're going to try example 5. This one's tough. Try to think about it at all, okay? Because this doesn't give you a definition. It just asks which ones are true. So I'm going to give you about 2 minutes, 2.5, give you a hint. I want to give you a hint, okay? So it gives you a table of selected values. Does it give you the values of F or F prime? So really quick, if F prime is positive, what does that tell us? That the function is increasing, right? It's on its way up. F prime positive means the function's on its way up. Now look at, they don't give you an x value of -1, do they? It's possible that the value of -1 could produce an output of F prime of a value of, say, 4 or 0 or of -2. You don't necessarily know, whether this stays positive the entire time or whether it changes to negative or whether it goes to 0. You don't know that, okay? So I'm trying to give you that as a little bit of an idea as you look it through, okay? 5, 4, 3, 2, 1, and 0. So here we go. All right. Relative extrema. That means local max and local min. Those happen when F prime changes from positive to negative or from negative to positive. Do we know, do these ever change to negative? Might they change to negative? Do we know? So we can't say that for sure. A critical point is where F prime is equal to 0 or F prime doesn't exist. Do these ever have to be equal to 0? No. Increasing. That means f prime is always positive. That's the most likely choice that people would pick for this answer. Do they have to stay positive? No, they could, like we said, at a value of 1, it could drop down to -1. That might happen. We don't know. So it's not that. Here's what I want you to look at. I want you to, because the other two consider the second derivative. Second derivative is the rate of change of the first derivative. Am I going up or going down? Ooh, so everybody agrees second derivative is negative? Somewhere? Going up or going down? Oh. So if I change from concave down to concave up, that means I have a point of inflection. Going up or going down? Up. Going up or going down? Oh, so I have a point of inflection somewhere there, and there I definitely have 2 inflection points in speed.